Welcome, everyone. Welcome, Dr. Han, our man in motion. Very glad everyone could join us today. Thank you, everyone who's joined, who's been with us so far. Had a couple of really great talks today. It was really great to see the participation. We have a very special session today. I think this is sort of the gem of the conference. This is a panel discussion. We have been blessed with some very well-recognized names in this industry. I'm going to run through and try to do as quick of an introduction, because if I read the full introduction on everyone here, it would take the entire time. So we have with us today Rachael Lemus. He's an extension research professor and extension forage specialist in the Department of Plant and Soil Sciences at Mississippi State University. He also serves as the leader for the Center for Forage Management and Environmental Stewardship. Welcome, Rachael. Mark Westerhaus has been applying chemometrics to NIR data since 1978, when he joined John Shenk as a graduate assistant in statistics in a project funded by the USDA. In 1983, John and Mark formed InfraSoft International to provide software and calibrations to the feed and forage industries. Mark became president of ISI when John Shenk retired in 2005 and held that position until ISI was closed by FOSS in 2010. Mark worked as a senior chemometrician for FOSS until his retirement in 2018. Some would say Mark needs no introduction. Notable achievements include just little things like MPLS, instrument standardization, local repeatability files, and WinISI. So if anyone's heard of any of those things, maybe some of you have. Thank you for being with us. Dr. Kun-Jun is an associate professor at the Louisiana State Agricultural Center. His current research activity focuses on improvement of production and utilization of forage crops, development of feedstock analysis techniques targeting biofuel, and collaboration with extension faculty members through on-farm presentations. From 2014 to 2015, he served as the president of Louisiana Forage and Grassland Council. Thank you for being with us today, Dr. Han. John W. Shenk has been part of software development teams, calibration development teams, and instrument development teams, spanning 35 years, with emphasis in specializing in the feed and agricultural marketplace. Thank you for joining us, John. Phil Goldblatt has been employed at Dairyland Laboratories in Arcadia, Wisconsin since 2014 and has been the NIR manager since 2017. He is responsible for calibration development and maintenance on benchtop NIR instruments and also administers Dairyland's network of affiliated laboratories. He has experience with calibration development on several portable NIR instrument platforms and has served on the board of the NRS Forage and Feed Testing Consortium since 2019. Welcome, Phil. And then from Bluesun here, we have Rachael Glenister. She is the North American Sales Director for Bluesun Scientific and current president of the NRS Forage Testing Consortium with a BS degree from the University of Notre Dame. She started her career as an NRS application specialist with Perkin-Elmer in 2014 before transitioning to a role as the regional sales manager with Unity Scientific in 2015 and joined the Bluesun Scientific as the North American Sales Director in 2020. Rachael, thank you for being here. And last, but certainly not least, Philip Ossowski is the Director of Applied Technology for Bluesun Scientific, where he oversees implementation of forage calibration provider databases, including standardization procedures. He has 5 years experience in NIR application development, a master's in science degree in bioresource reengineering. Welcome, Philip. I think I got everyone. So I don't want to put too much of a structure on this, but it's such a unique opportunity to have people with such depth of knowledge, but different perspectives. So we have people from commercial laboratories, we have NIR authorities, we have people involved in university and research programs. So we are interested in picking the brains and generating discussions where different perspectives on the same topics will yield interesting conversations. So we have some pre-planned questions, which I'm going to save just for a minute, in hopes that some of our attendees have some things that have had them scratching their heads or they need some interesting expert input on. So as Rachael mentioned, there's a Q&A button. If you click that and you type in your question, your thought, or your comment, we will read it aloud and hopefully get some very interesting discussion. So our first question, I think our first thing is Pierre Dardenne says, "Hi, Mark." And then our second comment is addressed to Rocky among others, but I think let's keep all questions to the panel to get different insights. What is better for assessing market forage quality, RFQ or RFV?
I think it depends where you at, but I think from my perspective, RFQ is a better assess of the market because RFV was developed mainly to target alfalfa. So if you're still only looking at the alfalfa market in the West, or you're looking at alfalfa market overseas, going to China or Asia, probably they're going to depend more on the RFV. But the RFQ allows us to actually make a better comparison. And the reason for that was because RFV do not take into account the high fiber content of grasses. Therefore, the grasses were getting penalized when you try to compare grasses based on the RFV. By going to RFQ, what you're doing is you're still accounting for that higher fiber content of the grasses. But when you do that, also usually a lot of this grass, even though they have a higher fiber content, a lot of that fiber is more digestible, sometimes more than alfalfa. So by doing that, I think if I'm looking at the market overall and comparing alfalfa and other grass species in there, I will prefer to go then to the RFQ model more than the RFV model.
Thank you. I hope that answers the question, but if any other panelists want to expand, it's open, or should we mark this question addressed? Okay, getting some head shakes. So very good. Thank you, Rocky. Our next question may be directed to Mark, but again, open panel. Can you explain why NIR can be more accurate than wet chemistry?
Very good question. The answer is yes, it can be, and it's because NIR calibrations kind of include an averaging aspect to it. The simplest calibration would be to just take the mean. As you know, the mean really reduces the variability of the individuals over the individuals. And as we do MPLS or PLS or many of the calibrations, they still have that averaging aspect of averaging out random lab error. So an individual lab assessment can have its lab error, but when you feed the spectra into an equation, all of the contributing lab errors tend to be averaged down quite a bit. So yes, it can be more accurate.
Very good. Thank you. Any other panelists want to share their perspectives? Okay, all right, very good.
I guess I would just jump in there. The question addressed how it can be more accurate. I think it's probably been said in some of the previous talks already, but not only can it be more accurate, but I always like to mention that definitely can have benefits in terms of precision when you're doing analyses. And I would gather probably the biggest benefit to precision would just be that it's a very simple and kind of repeatable procedure as far as how you present the sample to the instrument, and go ahead, you eliminate a lot of the different problems having to do with sample preparation that involves a lot more complex procedures for wet chemistry processes, and also just the amount of training that you might need to do. So there could be a lot of lab error related to the operator, related to different pieces of equipment, related to expired solvents, etc. Whereas with NIR, you can make a strong argument that you'll get better precision just because we've eliminated so many of those different things during the sample preparation and analysis itself.
I can add to that as well. So for at our lab, we do control charts and check samples for all the analysis that we do. And we'll pick out starch, for example. We do a corn silage check cell for all of our NIR instruments in Arcadia, and the standard deviation across all of our instruments is, I think, about 0.35% on the NIR. If you're looking at the chemistry method, that's the standard deviation is much higher than that. I believe it's over 1.5%. So in practice, the NIR is absolutely more precise than the chemistry method is going to be.
Well, I would say, maybe precise, but accuracy is not as good as wet chemistry. I think we understand that point. Without, accurate analysis and the good sampling technique, NIRS is developed on the, wet chemistry analysis. So if we compare the accuracy, wet chemistry would be better than NIRS. But the good thing of NIRS is that more, as he said, precise, and also conventional forages, the analysis is more or reasonably acceptably accurate and very good precision. That's what I'm thinking. Thank you.
Thank you. Thank you, Dr. Hunt. Oh, very good. Lots of different insights. Thank you, everyone. We have a question. I'll pose it to the entire group. This is, I think, a very interesting one. Where do you see the future of calibration development going?
I think we're going to see an increase in calibration development as new technologies come into the market. Going from our standard benchtop type of instrument to now having portable instrument to some companies incorporating that into their balers and cutters to try to get a better idea of forage analysis in real time. We see a lot of this technology going also into drones. We had done some work here at Mississippi State, calibrating drones with spectra from between the drone images and spectra collected in the drones and the one that is in the bench top, so we can do real time assessment of either hay fields, or if a producer is going to go on and graze a pasture, what is the quality before I put the cattle in there, and what kind of gains I can expect. So I think we're going to see that there's going to be an increase in the number of calibrations coming up. I think there's going to be different companies involved on this. I think it would be great if we all put the effort into having more uniform calibration, standardized calibrations that can be used across different platforms instead of everybody just going in different directions, which it encouraged the problems what we have sometimes where producers, they say, well, I tested this lab, it's higher than this lab. So if we can standardize the system and be more in tune between those calibrations, we might see a better output, a better utilization, and a better economic return for the clientele that we serve.
Was kind of in somewhat of a different vein, but the question being, where do you see the future of calibration development going? One thing I've tried to look into more just as a matter of casual interest, but is basically where we can see the concepts of machine learning and AI kind of, let's say, through ChatGPT, OpenAI, some of these new platforms that have come out, and how that's going to change the kind of the landscape for calibration development, whereas in the past a lot of these things have been done manually or semi-manually. We have software and different equations being run through our software, but I would suspect that there's going to be a huge element of AI involved in the future. Now, what that might look like exactly, I can't say. I recently asked ChatGPT if it had any ideas on where it could take NIR calibration development, and I had a lot of great answers. It's a very smart smart thing. So if it was well prepared to answer my question and exactly what it could do, and I wish I had a little bit more detail on how it responded to me when I posed the question, but I think that'll probably be one of the big steps coming up in calibration development in the future.
I agree with you, Philip. I think we're going to see this happening. And, there's this company in Israel already that is now using an app that actually you can scan the sample with your cell phone and it's try to estimate what the nutrient value of that sample is. So I think we're going to see a lot of changes coming up where it might be readily available to in our mobile devices to get some estimation of nutrient value. How precise it's going to be, I'm not sure yet.
Yeah, and that's kind of one thing I've tried to think about is I've seen a lot of new technologies come out, small startups, et cetera, that have what I'll call lower cost technology that definitely are nowhere near as good in the traditional sense as monochromator based system, diode array based systems, but they seem to put a lot of emphasis on their ability to make calibrations based on what that particular technology is able to produce in terms of spectra. So kind of where I'll be curious to see down the road in terms of what happens will be how these AI systems can possibly generate models that we couldn't have even conceived of, or possibly different techniques of processing the data that we just don't know or haven't. I don't want to say we haven't tried. I'm sure veterans of the NI industry have tried nearly everything in terms of getting information out of the data, but we're dealing with these new systems that are going to take us in kind of a crazy direction. So it could be that the sophistication of the hardware may not be as important down the road. Now, is that completely true? I kind of invite everyone else on the panel to opine on whether or not like I said, the sophistication of the equipment will eventually need to change. But kind of like you were saying, there, these smaller probably get involved in how the handheld equipment is used and probably eventually lower the cost of the hardware. So that's kind of how I see it, and curious everyone else's thoughts.
You've stared at this stuff longer than anybody, and you've looked at all the other instrumentation more than most of us. What is your take on this subject? Are we headed for Buck Rogers, or are we still, kind of where we are? Mark.
Yeah, I don't know. One question I can put out to the panel is, do you think we'll be shipping the spectra over the internet for analysis on the server someplace, or is it truly going to be handheld and processed locally? I don't know which way that's going to go. The software is probably going to get more complicated, yet the hardware to support that's probably going to be catching up fairly soon. I also think that a true expert in the field has some creativity, but mostly just follows a set of rules he has in his head. And if that's the case, you could probably have a computer do as well, have a program do it as well. So there's that going on. I don't know that we need to use the existing AI tools, but we used to call it knowledge engineering, I think, to try to see what the experts are doing and try to codify that. So I still have some hopes that could lead to some advances.
Yeah, I guess I'll kind of echo that a little bit. As far as the general set of rules, I'm pretty much a straight down the line when ISI user for the most part. And I think that there's a set of best practices that we use to generate a variety of different potential updates or new models. And then we evaluate them on some validation sets. But I think that it's a very automatable process. Even if the math that we end up using doesn't get more complicated than PLS, I know there are other options out there now. But even if it doesn't get more complicated than that, I think it's very automatable in the future.
Yeah.
Yeah, and up to your first point, Mark, if I understood it correctly, I do get the feeling that the processing of these calibrations and processing of the data probably is going to stray more toward the computations taking place in the cloud, so to speak. I get the feeling we're going to see less and less capacity for doing these things, locally on the instrument. It'll probably all be networked and all be done, be it for IP reasons or just for the computational power needed. If you can kind of remove the necessity for a high-powered computer on the actual piece of hardware and defer all of the math and processing to a server halfway across the world, you know, that almost, it makes sense to do it that way rather than carrying around more hardware than you need.
Yeah.
And that's happening right now. Do we see that already? Those spectra are being shipped on the internet, and that company that I mentioned from Israel, that's what they do with the mobile app. They're shipping that spectra to the servers and sending you back the results. So I think as we move in that direction of this company collecting the spectras, you know, I wonder how many spectra they're collecting that are improving the algorithms and the accuracy of prediction models by having that spectra readily available to them on the cloud. But also, you know, we've seen now, you mentioned WinSI, I use WinSI all the time, but now you see a lot of these new prediction models being developed in R. So I think we see a lot of changes in technology in how we actually using different software packages that are really accessible to really move forward the question development and prediction models.
You know, I'm a little bit of a purist, as you all know. I came up through ISI, and then I helped develop the UCal software for Unity. I'm currently helping another project develop another calibration software currently. You know, back early 2000s, at ISI, we came up with the concept of, or 16, 18 years ago, we came up with the concept of shipping spectra across the internet, predicting on the cloud and sending the data back. We came up with that concept in 16, 18 years ago. It worked. We proved it worked. We put it in the software, and the company that was running the system at that time thought, no, this is a bad idea, and they yanked it. Okay, they were worried about patent concerns, and they were worried about speed of computers, and they were worried about all these things that we're talking about. Okay? So I don't see it personally. I don't see a lot of advancements in here. When I talk to my fellow experts, Pierre Dardenne, Mark Westerhaus, and so forth, they talk an awful lot about going back to basics. They talk an awful lot about, well, neural networks, which is kind of a machine learning thing that FOSS does. That works, okay. Local, which is what we did for ISI, that works okay. But the more I talk to these experts, these people I've known longer than I've been in the game, say, no, I think we should go back, and we should go back to the basics. We should go back to understanding these things on a simple level. The idea of sending spectra across the internet and doing all the calibration work, yada yada, I'll do all that on the internet. That idea is 20 years old. So I'm not overly excited that people are doing it, but I think we should be more focused on using the right calibration techniques, using the right procedures, like Phil said, and getting the answers as accurate as possible. Now, if across a cell phone, fine, but we should focus more on the basics, getting the things right before we jump into, let's send it across the internet and make it fast. That's my 2 cents.
I appreciate Dr. Shenk's comment, and also I'm wondering, I'm a wet chemistry user. I was, and I'm doing that. So my joining to the consortium was kind of a last year, so it's very short. So I wasn't involved in the calibration model development. My question is, some producers wondering, silage or haylage analysis, the nutrient component is quite similar to other hay or, other type of forage. So, but the silage is different. There's volatile fatty acid. I understand it's hard to determine or calibrate it, but in the future, is there any kind of, possibility we can do that, do those kind of components?
I think so. There's work going on right now, Kun-Jun. I know the consortium is going to start looking at some of the other parameters that can be incorporated in some of these equations. So I think I'm not sure how soon it will be, but I think down the road, I think we might see some of these new components coming into line into some of the calibration equations. We'll have to do extensive testing to make sure that there is accuracy on those new parameters being added.
I'm
Is
sorry.
everyone happy with the agreement among labs for all these constituents?
Okay. You know, BFA or pH, those kind of, you know, silage limited nutrient component or chemical component are very important because it, you know, determines the intake, potential intake of those type of forages. So yeah, yeah, of course, good quality silage has high crude protein and low, you know, fiber. But I think other component, as I mentioned, you know, the inclusion of those components would be better, you know, tool for suggestion of you know, ration for dairies and cow calf operations. Thank you.
So do you mind if I jump in here? If you send a sample to Dairyland and get a Dairyland NIR report, if it's a big enough one, you can get lactic acid, acetic acid, ammonia, pH on your silages. And I can show you calibration statistics for those calibrations that say we're measuring these with some degree of accuracy, and I can show you validation stats that say the same. But I think when you're looking at, you know, a lot of these fermentation parameters, you're running into a big problem. So we are drying and grinding all of our samples for any NIR that we're doing in the laboratory for silages. So those analytes that we want to measure, some of them are being driven off in the drying process. So when you're looking at some of these analytes, you're trying to measure what was there in the beginning, not what's there in the end with the powder. And I think, you know, if you're in a place where it's very difficult for you to get wet chemistry analysis on these analytes, I think it's definitely statistically better than guessing a book value. But it's important to keep in mind that we're not actually measuring with the NIR all that was there in the beginning.
So I think from the sample preparation steps, I think there is a limitation for predict, you know, silage quality. So I don't know much about the mechanical or, you know, fundamental thing of NIRS. So yeah, I'm sorry for my ignorance, but if there is a kind of calibration model can reasonably precise to run the wet sample, just skip the drying process, then we can preserve the, you know, BFAs and you know, other fermentation product estimation or prediction is possible. But I don't know what's the, you know, technical hardware wise is following the, you know, the demand.
We had before we started this session, a few people ask us to introduce a question, and it's so, I think, closely related to this. I kind of want to interject it just a little bit. Sorry for interrupting a little bit, but it's such a perfect time for this. How do you decide and validate when a parameter is suitable for NIR analysis? So in introducing things that maybe aren't traditionally done, I have some specific examples, but as a general question, I know this is, yeah, I don't want to start any wars, but what does everyone think?
Well, if from an applications guy, generally I will ask the customer, what are they willing to put up with? If they basically, if you're looking at it, you know, it really just probably depends in some situations, at least, you know, what is the tolerable error of your calibration or error upon validation? What are you willing to put up with? I can't really speak to individual applications, especially relevant to forages. Those are probably reasonably well established, or at least every different calibration powerhouse or developer will have their own idea of that. But like I said, there is kind of, for me at least, an element of try it, and if you're happy with it, you're good to go. And that probably speaks to the importance of the constituent you're reading. So if it has to do with the health of the animal, then there's probably going to be a lot more scrutiny, and you're going to want to see very good results, versus if you're just wanting to estimate something and you don't feel like running an expensive test, you might you know, might not be as strict on your validation.
Yeah, I would echo what Philip is saying as well. I mean, independent of forages, you know, we sell a lot of NIR, or we place a lot of NIR analyzers into the broader food and agricultural marketplace, and it just largely depends on, you know, what is the expectation, what's the ultimate goal with the data, you know, and where is that tolerance, you know, how accurately can you analyze your samples currently with your current methods? What would it mean to implement a more rapid, non-destructive method? And so we use that as our goalpost.
Looks like you can do an economic analysis of each variable to see how important it is economically to get the right number. I assume there are some cases where it doesn't really matter that much, and then if you're better than book value, it's probably good enough. And others you need to really concentrate on.
And then, of course, kind of more on I guess on a technical note, I think I generally reference that, I forget the actual value, but as far as what we can expect from NIR in terms of accuracy versus the wet chemistry method, I think we say it's usually either from 1 to 1.5 times the error of the wet chemistry method is what we can kind of expect. So if we're far outside of that, then that kind of throws things into question. But if we can fall within that 1 to 1.5 times the standard error of calibration, then that's at least a good kind of little test to see if we've got something working well. And maybe others have better kind of insight on how far you want to see that error in terms of difference. Let's say if you're comparing it versus a you know, do a blind comparison test on your wet chemistry method. But like I said, usually we can kind of gauge it from that 1 to 1.5 times error range.
Yeah. Not the biggest fan of that rule of thumb.
You're not convinced? I'll defer to you, Mark, because you definitely know more than me on
We've done
that.
studies where we just added random error to the lab numbers. So those statistics you're talking about get influenced, but the calibration really doesn't care. It swallows it just fine. Calibrations can swallow random errors very easily.
True,
So,
true.
Okay, thank you, everyone. Very interesting insights. We've had a couple more questions come in, so I'm gonna open it up again to the audience. Question to all panelists: do you think the handheld NIRS gives sufficient precision and repeatability to replace benchtop instruments for diet formulation needs? This may be of importance for commercial feed consulting. Thank you.
I don't quite a bit of work in this comparing benchtop and portable systems. Right now, I will say no. And the only reason that I go with that answer is because most of these portable handheld instruments are coming from Europe. One, the calibrations are not suitable for a lot of the crops that we have in the US. Two, some of these instruments do not have an easy way to update their calibration models. Agrineer is one of those that is complicated and hard to get into software. And if you try to get somebody from Dynamic Generale in Europe to help you, it's been 4 years. I can't get anybody to answer my emails. I finally got somebody called me that has a rep in the US, and that was 5 months ago. I never heard back from them. So it makes it very difficult to justify $25,000, $30,000 in a handheld instrument that you cannot upgrade with new equations or modify the equations to fit what you're doing. So I think, when I look at also the deviation between the same sample that's run on the benchtop and is run into the portable NR system, sometimes we have about 3 to 10% variation depending on which constitution you're looking at. And if you develop in a ration, that's a lot of money that's being wasted. So I think we have to be very careful right now how to utilize these portable handheld systems to make recommendations to a producer and the economic impact that might have behind it.
I'll second Rocky's answer and say, no, I don't think it's good enough for the formulation right now. That doesn't mean that there's not uses for these instruments that I think are extremely helpful in the field. I think like we can manage moisture pretty well, or use that to time harvest, that sort of thing. But as far as ration formulation, I don't think we're there, and I'm not sure it's feasible.
I think
I have an opinion,
Frozen,
Josh.
Phil.
I have an opinion. Can portable analyzers do ration balancing? Okay. First off, any tool that helps the farmer get more numbers on a repeatable basis more accurately can save him time and money is valuable. Now, I know that there are visible detecting analyzers out there that only get dry matter. Okay, now if I can get dry matter, I can save myself a lot of hassle feeding dairy cows, just simply dry matter. Now, it's not accurate, but it's consistent. So it has a place. I don't agree with the large companies pushing some of these devices that they don't really understand, and they're just pushing the latest whiz bang. Now, when you move up into the spectrum, you move into the diode array area of the spectrum, you're going to get a little more. You're going to get dry matter, you're going to get protein. With some luck, you're going to get both of those, and they're not horrible prediction-wise. They're not great, but once again, anything in a farmer's hand to give better answers helps a lot. Now, there's a cost ratio. So if someone walks in the door with an instrument that's $25,000 and you get dry matter, okay, that's not really worth it. You get protein, well, if you have enough cows, maybe that's worth it. Maybe, depending on how many cows you have. Now, if you could stretch that into fibers and ADFs and NDFs, well, now you're getting more and more importance. So the rule of thumb that I always stuck with was when we developed the portable instrument that I had, it needs to be about $13,000, maybe 15. You need 5,000 cows. You need to get dry matter protein, and you need to get a good guess at ADF and NDF. If you can get that, and you can get $15,000, it'll pay for itself and it'll work. But right now, the market is so clouded with different solutions, and you have large companies pushing ideas and pushing pieces of equipment. And from what I see in the landscape right now, I'd be hesitant to try anything. I like the wet lab, even though it takes 3 days to get an answer, and UPS, you got to pay for that. I understand all that. But a good benchtop analyzer will get you more accurate answers. And you just might be okay not needing those analysis quickly or on the spot. So.
Yeah, I think John hit on a really good point there. That's certainly important to note, is like the price point that the fit for this particular analyzer would need is prohibitive to the technology quality. So those are not really in sync. you need an analyzer that's at a $13,000, $14,000 price point, but the technology needs to be sophisticated enough to give you, sort of accurate analysis. Those are sort of competing, specs there as well. So, and then Rocky's point is certainly well taken as well with, local service and support is certainly incredibly important when it comes to any sort of NIR, the application of any sort of NIR technology.
Well, the way I use the one I have, I use it like Philip will say, it to help that producer to get along and to be a better forage manager, better hay producers. So what I use mine is usually producers that I have working with throughout the state. We use it to monitor. Okay, if we take a sample, you're about 10% or 12%, and we know that it's getting to that point, I can tell, say, in another week, you need to start thinking about this. Or, your fiber is going up too high right now. Think about cutting it, because we need to look at those systems and how we can help them to manage that. But we use it for there, and then once we harvest it, and we wait 2 weeks after that hay had gone to some of part of fermentation sweating process, will be more stable, we can take a sample and then send it to your lab and say, hey, now here's the analysis. And we can take one with the NR system. We can see those differences too and say, here's the big difference that you have, and this is why we need to do this. So there had to be some educational part behind us as field technicians to make sure that the end user understand the quality of the data they get and how they can use it and what the objective is, especially from the economic point of view.
You briefly touched on our next question already, so I'll open this up. What are the limitations of fresh versus dried and ground samples in NIRS analysis? Is accurate in the field forage quality analysis possible? So we've talked about some of that a little bit. Maybe discuss the limitations of fresh versus dried and ground.
Yeah, well, and that was a point I was just about to make at the end of Rocky's response there, is that the handheld is a really useful device for being able to do it. But another thing to remember, not only the price point being a big issue, but also the amount of work that's involved in preparing the sample for use on the benchtop instrument. With a handheld, chances are customers not going to also invest in a grind Wiley mill and a cyclotron and an oven, and going to spend the time to oven dry them, then bring them in front of their little handheld spectrometer. So there's kind of a whole infrastructure built into using these benchtop instruments as well. So, whether or not the portable instruments have good performance, it also depends on just how usable they are for the farmer, et cetera. That was just what I was going to add there, and then I'll kind of, I'm sure others here have more eloquent ways of describing the difference between wet versus dried analysis.
Well, I think you can't really appreciate, in my opinion, the effect that water has on the spectrum until you look at a spectrum of the as-is sample, dry it, grind it, and put it on the same plot as the dried and ground sample. All the same material, put it all together. When if you're looking at like a corn silage with 70% moisture, there's very little that you can see besides the moisture peaks. And when you have so much water in the sample, it's going to cover up a lot of the spectral features that I think are really important for making good NIR predictions for fiber, starch, those types of nutrients that we are more interested in. So in my opinion, I think that it's a very difficult hill to climb if there's a lot of moisture in your sample to get accurate results.
It is, and as Phil, I've seen that with the portable instrument, when we take samples that are at least more than 50% moisture on it, we get an error. And it's because it cannot make those predictions very well. Most of the equations that we usually use in the benchtop have been developed with maybe a 90% dry matter, 10% moisture on it. So when you change those numbers, we'll see those those huge differences, and especially in the prediction equations of how to calculate those in dry matter. We see a lot of skew results on that. I think David McIntosh at University of Tennessee had done some of that work for his PhD, and I think he's supposed to present tomorrow, so he might talk some about the issue with dry matter. So it will be an interesting talk.
I will just add, I don't think, he was planning on, he had some personal matters he had to leave, so I don't think we would love for him to join, but we're not planning on David McIntosh being here tomorrow. But yes, that is the nature of his work.
Josh, there's another question in here that directly relates to this. So
Wait. Let me ask a question, Rachel. Mark, you were part of the team in the 90s, early 2000s that developed calibrations for undried, unground forages, hay, haylage, corn silage, high moisture corn, grain, hay, the whole gamut. And we marketed and sold those through the Foss Company at the time. What do you remember about the success of those calibrations? Because I don't have a clear memory. What do you remember about the success of those calibrations and how well they worked? And were they important?
A lot of questions.
I know too much.
It wasn't as good as dried and ground, but I don't remember much more than that. I think your father would have been more involved.
Yeah, okay.
There was a question referring to kind of what you're talking about now. Why not mask out the moisture peaks and focus just on the remainder of the spectrum?
Moisture is everywhere.
Very good.
The moisture peaks, they expand over the whole region of the spectrum that we look at. It has some contribution at all wavelengths. It's concentrated at certain areas, but it's not absent anywhere.
Very good. Thank you. Someone asked, John Shenk commented on quality of the hardware, being able to determine nutrients beyond dry matter accurately. How does quality of hardware overcome that moisture peak?
In an undried world or in general?
They didn't specify, so I'm going to assume in general.
Okay, so
an undried, unground world.
Okay, in an undried, unground world. Okay. My dad used to say that spectra, the spectra that is redundant as you move across the spectrum. Okay. And as Mark can attest, the software uses highly mathematical procedures to sort out the differences and where things are. So if you have a high piece of equipment, I have a high piece of equipment sitting here beside me making funny noises. It makes consistent spectra. It makes spectra that is every 1 nanometer. So it gives me more information. Like I said, to be every half nanometer to get me more information. Okay. Then if you apply the right software tools and you apply the right mathematics behind those, undried, unground will work with a high-class monochromator as long as you try very hard. Now, it's never going to be dried and ground. Remember, it's based on dried and ground. So it's never going to beat dried and ground, but it will give you accurate answers. It will give you accurate answers over time, and it will give you consistent answers. I'm done.
Okay. We have another question. Thank you, John. And we're wrapping up our hour here, so maybe time for one question after this one, but we're near our end. They addressed it to Phil. I think it's again to all panelists. Recently, we received a complaint from one silage inoculant supplier on high content of acetic acid we had found in a corn silage sample. We dry samples at 60 degrees Celsius, supposing this is gentle enough to not vapor out the organic acids. Could we correctly predict the silage acids content by NIR using this drying method? Thanks.
Yeah, so I think the more gentle your drying technique is, I would imagine that when you get the sample dry, you'll be closer to having the correct percentage of acids that were there in the raw sample. So if you dry at 100 degrees, for example, you're probably going to drive off more than at 60. There are other variables too. So, you know, some ovens use different mechanisms to dehydrate the samples other than just heat and forced air. There are a lot of variables, but in general, I think the more gentle your drying method is, the closer you're going to be able to be on those volatiles or semi-volatiles, I guess you would call them. The problem with that is if all of our other models that we're analyzing for the sample are built on the 60-degree dried sample, and now we're throwing a 30 or 40-degree dried sample at it, well, then everything else might become inaccurate. You know, I'm generally pretty critical of the as-is, undried, unground scanning, but I wonder if the fermentation acids might be a good application for that versus drying and grinding the sample.
Thank you. When we had, thanks, Philip. I see a question. I hate to ask this with 3 minutes left, but it is from someone I know well and appreciate. She has asked, what is better, global calibrations or local calibrations?
Like this is a question
I
for
think
John and
Mark, I think Mark is the answer for that one, because Mark wrote them both. So we'll let Mark answer that one.
Okay, so it depends how you use local. Going back to the history, local was developed when we had a wide range of forage grass ratio samples, from pure grass to pure forage. We could not put them all into a single PLS model and be happy with the results, but we were able to then use local to pick out similar samples to the one that needs to be analyzed and do a quick and dirty calibration for that one sample. That's what local does. And so in that case, it works very well. Some people think you can throw apples and oranges into the same local calibration and it's wonderful. Well, I say you're not really buying anything. You're not getting any improvement, and there's a possibility of getting a misclassification mistake in there. So there's really no upside and a potential downside. So you have to be careful what you put into your local calibration for it to really give you an advantage. There's the number, of course, if you have under a couple hundred samples, I think you need to go PLS, not local. I like to have 2,000 to 10,000 maybe in a local calibration to do a good job. So that's another factor. Typically, we would start with PLS because you can do that with fewer samples, and then try local and see if it gives you an improvement. It depends a lot on the variability of your product. If you're looking at a finished product, for instance, you probably don't have the excessive variability that warrants local. PLS will probably do just fine. So local is helpful when your problem is too broad for a simple PLS model to handle. Okay.
Well said.
Anybody with experience going to talk now?
Can I jump in here? I don't know if anyone else had anything to say on this. If not, we've never actually used local at Dairyland, to my knowledge, at least in my time, to produce results for customers. But that doesn't mean that we haven't played with it. And as far as accuracy gains have gone, I've seen some in some cases that made me think it's attractive. But where I got in trouble with local was having results for different nutrients not really make sense relative to each other. So for certain nutrients, if we have certain values like the UNDF or NDFDs, for example, where the values are very similar to each other that go on a report. And through random variation, you know, sometimes the error on both nutrients, if you look at a validation set, would be equivalent and fine, but you have 24-hour NDFD lower than 30-hour NDFD, which is not possible, right? We can't print that on a report. So for local, I never really figured out a way to keep that from happening, where with PLS, there are ways that we can structure our series of models to make that not happen. That's just a personal experience, not necessarily based on overall accuracy, but on generating a report for all nutrients that make sense local. That was a limitation for us.
But you had to play some games with PLS?
Yeah. So basically we would need to have very, very similar, if not identical samples in the models for each of those nutrients. So for example, if you're doing, from my understanding, if you're doing local and you don't have the full set of the time points for each one, you might not end up with the same set making the calibration for local correct for the 24 and the 30.
Correct. Every sample has its unique set of similar samples.
Yeah, so I think that was a limitation for us when we tried it. But
that's the one downside people often report, is that it's less repeatable. Even if you take the same sample and scan it twice in a row, there's a chance that you may have one or two samples different in the selected sample sets. And that's enough to give you a larger difference in predictions than you would get with a static model like PLS. These errors are still much, much smaller than your accuracy for that calibration. So it's mainly a perception problem. So the accuracy, the claim is that the accuracy with local is better, but the repeatability is slightly worse than PLS. That's not quite addressing what you had, but just a kind of additional comment there. But it's usually worth it. If you look at the improvement in the overall error, it's usually worth a little bit of an increase in the predictability, repeatability. Anybody else?
I think that's a nice note to end at. We're at the end of our hour. Thank you so much to our panelists for the very lively discussion. Thank you to all of our attendees who have participated. This marks the end of day one. We will continue tomorrow beginning at 11 a.m. Eastern. We hope you continue to join us. We know some people have scheduling issues, but we hope you can make it. We will wrap here. Again, thank you, panelists. It was a treat having you.
Thank you.
Thank you, everyone.